Hello everyone and welcome back. In this episode we are implementing a spatial hash grid instead of a normal spatial grid. The advantage of spatial hash grids are, I think, they are easier to implement. You need less code and you're not restricted to a world size. Right now we are restricted to a world size of of our canvas. That's our world size. But you don't need that anymore. You can go basically unlimited in each direction. And this is only limited by the numbers you can represent by integers or long integers. Yeah, we are gonna create the scene with a lot more circles. I think without the rectangle though. Um, and yeah, you can see 1280 bodies instantiated here with a constant 60 FPS using JavaScript. I think that's a pretty good performance for this engine. Yeah, I guess let's jump to Visual Studio and let's implement our spatial hash grid. Okay, that's our that's the code from last episode. We will create a new file in optimizations, and this will be called hashgrid.js. The hash grid, I will do it like this. I'm gonna extend it from spatial grid. So extends spatial grid. It's gonna have a constructor too. Even though we don't need cell size. Well, actually we need cell size. Oh, 1 second though. Constructor. Wait. Oh, I'm confused. Help. There we go. Yeah, then I'm gonna say super cell size. All right, there we go. Then we have a hash map. Um, I'm not quite sure what's the equivalent to C sharp. I think in C sharp it might be maybe a dictionary. I'm not sure. I think it's a dictionary. Also in Java. I'm not quite sure, but I guess you can Google that. I don't think you have problems finding the right data structure. Then we have a hashmap size. This hashmap size should be large enough to hold our cells, but I would suggest set the hashmap size to a larger number. Then we have a prime number, p1 prime. We're gonna use this weird number. It must be a high prime number. You can use any high prime number you want. I'm gonna use this one because it's in my source code. And p2 prime. And we're gonna use these numbers to create an index for our hash map. And the higher these numbers are, the less collisions are in our hash map. What do I mean by collisions? If these numbers are too small, there might be the case that two rigid bodies will end up in the same cell, though they are not colliding anywhere. This is a collision, and we can avoid that by setting our prime number pretty high. Also, we need to make sure that our hash map or the size of our hash map is large enough to hold enough cells so there won't be a collision by calculating the index using these prime numbers. Then we have the initialize function too. So there you go. Again, world size and rigid bodies. this dot world size is equal to world size, and this dot rigid bodies is equal to rigid bodies. Then we have our refresh grid again, and this will have this dot clear grid again, and this dot map bodies to cell. Then we have our clear grid. In this method, we're gonna clear our hash map. Oh, this dot hash map dot clear. We have our rigid bodies to cell. Gonna clear that too and set a new array. And then we're gonna iterate again through this list and create a new array for that. So I smaller than this dot rigid bodies dot length I plus plus, and here I'm gonna say this rigid bodies to cells. It's equal to a new array. All right, then we have the function cell index to hash. Here we're gonna calculate our hash index to hash. This is just a formula. Unfortunately I don't know where I picked that up. The formula is like this. Okay, sorry, I needed to sneeze. The formula is like this. X times this dot p1 prime. Then we have a XOR with y times this dot p2 prime. Then modulo this dot hash map size. This formula is also there's also a formula for the 3D case, and we are going to use this prime number, and I'm surely gonna explain that function again when we are going to the fluid simulations, especially then in the 3D case, because this is going to be a little bit difficult, I guess, that we're gonna get the neighbor search right. But yeah, that's gonna take some time till we get there. Then we have our map bodies to cell again, this big method. And here I'm gonna copy some things from special grid, and actually I'm gonna copy basically everything. There we go. Here I wanna remove, this one is alright. This one is 2. We are removing these things right there in the 2 for loops. Because here we're gonna use the cell index to hash. Okay, then we get a hash value, and this one will be cell index to hash. So we're gonna calculate the cell index from we're gonna calculate the hash for our cell index, and this is the x and y value. Then we have a hash. All right, then there might be the case that there is already a entry in the hash map. So we want to get first all the entries from the hash map. We're gonna say this dot hash map get, and here I'm gonna say hash, so all the entries from that hash. Okay, and if there's no entry, then we will have an empty array, just a null basically. And here we can say we're gonna create a new array. So new array is equal to a new array, and with a length, well actually no, with the rigid body from this index. Okay, again, we get a hash value, Then we say get us all the entries for these hash values. This will be stored in here. If there is no entry, this will be null. Okay, then we check. If there's nothing, all right, then we're going to create a new array, and we know already that in this array, in this new array, there's already one body, and this is this body we are we are iterating already. I mean, this it's the current rigid body. Okay, and then we're gonna say this dot hash map. We're gonna set the new array. We can do this by hash. So at the hash index, we say, or we're adding the new array here. Then we have a else. If there's already some entries, then we're just gonna say entries dot push, and here it will be this dot rigid body at our current index. All right, and then we have our mapping rigid bodies to cells. Here I'm gonna say again, it's the same thing but with the hash. There you go. This is our map bodies to cell, and I think the get neighbor riches is the exact, almost the exact same thing. So I'm gonna copy that too. Copy this one from spatial grids, paste it in here, and here we need to remove I think this one, right? I think there's almost everything in this one, or except the for loop. I'm gonna let the for loop survive my little wipe. All right, in this for loop we get the cell hash again, and we get it from the occupied cells, just like in the last episode. Then we get the riches, the rigid bodies in the cell, and I'm gonna call this riches in cell again, and this will be this dot hash map dot get for the cell hash. All right, then I'm gonna iterate through all the bodies in this cell. So I'm gonna replace this one. Then I'm gonna retrieve one body, the current body, Richie in cell. I'm gonna call this is Richie's in cell J. And then I'm gonna do that check again with rigid body, the parameter, unequals Richie in cell. And if it's like this, then we're gonna say neighbor rigid bodies dot push Richie in cell. Okay, and then we're gonna return it, and that's our method. All right, and I think now we can actually use this already. I hope I didn't make any mistakes so far. We're just saying grid is a new hash grid, and I think that's already everything. Okay, I think I'm just gonna set it to 50. Okay, as you know, I made some small mistakes. You need to add a new before the map, and I also need to add the hash grid to the script here. Okay, so just copy this line, replace hash grid, and also we can remove from the hash grid. We can remove now the clamping right there. So let's remove the clamping. There we go. This one, and this one, and also this one. All right, then save. Go back to the browser, refresh, and there we go. It's working. Awesome. I think I can increase now the amount of bodies. So let's see if 40 is still working. It's a bit over the top. Okay, let's change the box size to 10. Yeah, 10, 1040. Just trying a little bit. Okay, that's pretty small, but it still looks pretty good. I think we can also decrease the hash grid size. No, the cell size. Actually, where is it again? Ah, yeah, right. I think I'm gonna try. What if I'm gonna remove, or I'm gonna decrease the box, the hash grid size to 50, for example, 15. Like a little bit bigger than the box size. That means we are decreasing the amount of bodies inside one bucket, basically, one cell. And yeah, it's just a testing. Maybe the FPS will down, will go down now, but it doesn't seem like that. I think we can increase even the amount of bodies. So I'm gonna say, how many bodies did we instantiate? Okay, I'm not logging that. I think I'm gonna log that too. Didn't I do that? No. Okay. Yeah, then I'm just gonna say right after the create stress test, pyramid console.log this dot rigid bodies dot length plus bodies instantiated. Instantiated. There you go. Okay. To the browser refresh. Okay, we have 824 bodies. I'm gonna increase the number now. Let's say for the iterations in this create stress test pyramid, I'm just setting the value to 50. Let's see how many bodies we have now. 1279. Okay, we still have quite a good amount of FPS. I'm gonna increase the amount further to 60 now. Refresh. Okay, now the FPS goes a little bit down to 30. We have 1800 bodies. I'm gonna increase the cell size to 20 now. And let's say if that does anything. Yeah, a little bit, would say. But you also see we need to increase the solver iterations again, at least for one number, to make it stable again. Yeah. I think I need to increase it by a lot more. Now I have it 10. Yeah, I don't know. That's now a fine tricking, finding the right size for our bodies that we get the most out of the simulation. Yeah, but that's it for this episode. Thank you for watching. Now we are done with our optimization stuff. In the next episode, I'm gonna show you how we can add local points, and after that we are applying forces. Well, we can grab our objects and throw them around, basically. Okay, thank you for watching, and I hope I see you, or you will be with me in the next episode. Alright, then, have a nice day, and see you there.